Before we find the derivative, we will need to observe which rule we will be using first. For h of x, we see that this is the difference of the two terms. The first term is the power, and the second term is the quotient with the power. The derivative of a difference is the difference of the derivative. What that means is that we will need to find the derivative of each of the terms and subtract them. For h prime of x, we will need to find the derivative of 3.1x minus 2 squared and subtract the derivative of 1 over 3.1x minus 2, the quantity squared. But what is the derivative of 3.1x minus 2, the quantity squared? This is a function inside the power 2, so we will use the chain rule. We bring down 2, rewrite the inner function 3.1x minus 2, and lower the power by 1. 2 minus 1 is 1, but don't forget to multiply the derivative of the inside function. The derivative of 3.1x is 3.1, and the derivative of negative 2 is 0, so we don't need to rewrite it. Simplifying this, we have 2 times 3.1 is 6.2 times the quantity 3.1x minus 2. And this is the derivative of the first term only. To find the derivative of the second term, 1 over 3.1x minus 2, the quantity squared, we first rewrite this. This is not the derivative yet. We only rewrite this. Instead of the quotient, we rewrite this at 3.1x minus 2 to the power negative 2, so that we do not need to use the quotient rule. But we recognize that this is the power with the power negative 2. We bring down the power negative 2 and lower the power by 1. Negative 2 minus 1 is negative 3. And we keep the inside function, which is 3.1x minus 2. We then multiply the derivative of the inside function, which is 3.1. Simplifying this, we have negative 2 times 3.1 is negative 6.2. And we will bring the negative power to the bottom to make it a positive power. 3.1x minus 2 to the power 3. This is the derivative of the second term. Putting these together, we have h prime of x equals the derivative of the first term is 6.2 times 3.1x minus 2 minus the derivative of the second term is minus 6.2 over 3.1x minus 2 cubed. But a negative is a positive, and so the answer is 6.2 times 3.1x minus 2 plus 6.2 over 3.1x minus 2, the quantity cubed. For k of x, we observe that there is a function inside the square function, and so we will use the power rule. And inside, we will use the power for the first term. The root of 2 is 0, and for the third term, we would have to either use the quotient rule or rewriting this. Since this might be a little bit complicated, and so we'll let the inner function be u. U is 3.1x squared minus 2 minus 1 over 3.1x minus 2. Then k of x can be rewritten as u squared. And so what is k prime of x? It is 2u times du dx. But what is u? U is 3.1x squared minus 2 minus 1 over 3.1x minus 2, and then du dx. But then what is du dx? Du dx is the derivative of u. If u is 3.1x squared minus 2 minus 1 over 3.1x minus 2, then du dx is the derivative. This notation means derivative. The derivative of the first term, 3.1x squared, is 3.1 times 2x, which is 6.2x. The derivative of the second term, 2, is 0. The derivative of the last term, d dx, of 1 over 3.1x minus 2 can be rewritten as d dx of 3.1x minus 2 to the power negative 1. Using the chain rule, we have negative 1 times 3.1x minus 2. Lower the power by 1, minus 1 minus 1 is minus 2. But don't forget that we multiply through the inside function, which is the derivative of 3.1x, 3.1, the derivative of 2 is 0. And so this is negative 3.1 over 3.1x minus 2, the quantity positive 2 power. Putting these together, the derivative of 3.1x squared is 6.2x. The derivative of 2 is 0. And the derivative of 1 over 3.1x minus 2 is negative 3.1 over 3.1x minus 2, the quantity squared. We will now putting all of these together and obtain the derivative of k. K prime of x is 2 times 3.1x squared minus 2 minus 1 over 3.1x minus 2 times du dx, but we found du dx. Du dx is 6.2x plus 3.1 over 3.1x minus 2, the quantity squared. This is the final answer for the derivative of k of x.